Time for just a few IP version 6 nuts and bolts. And by that, we're gonna take a look at the version 4 and version 6 frame formats, the frame headers actually. Note the differences there, and we're also going to answer this question: why do we need version 6 in the first place? What in the world was wrong with IP version 4? And by the way, did anyone know that there's a number between 4 and 6 and it's 5? Well, let me answer that question first. IP version 5 does actually exist. It depends on whose documentation you're reading about why that didn't get widespread acceptance, but really version 5 was out there a little bit, and then basically I believe it was decided, hey, we need more improvements. So instead of building on version 5, they just went straight to developing version 6. So we did realize there was a number between 4 and 6. Version 5 again does exist, but you are rarely if ever going to read about it. Now, as far as why we needed version 6 in the first place, or what was wrong with version 4, well, in a nutshell, the main reason is that we were running into IP version 4 address exhaustion, which is a fancy way of saying, hey, we're running out of routable addresses. Now, NAT was really developed as a quick fix for that. It was not thought of as a permanent fix to the problem, and it was not thought that it was going to get as big and as prevalent and still be around at this point, but it is. But again, it was not thought of as a permanent fix to the issue. And that wasn't the only thing, though. It's kind of like you were living in a nice house with version 4 and you fix one problem, and then you look around and say, we could make some other improvements around here. That's pretty much what happened with version 6 with the elimination of broadcasts. Broadcasts aren't necessarily evil, but they can be a pain. It's not the most efficient way to get data from point A to point B, so they've actually been eliminated. Now, if you haven't done any route summarization on your job, that's fine, but the thing is, I know we haven't done it here in the course yet, but route summarization where we take multiple routes, break them down into binary, and see how we can represent them maybe with just one route, version 6 was built for that. Version 4 really wasn't. And with subnetting, with just a little bit of us looking at that subnet ID, you could see that subnetting is a lot easier in version 6. And it really helps keep our routing tables complete and concise. We loved that. So version 6 was really built with summarization and subnetting in mind, where version 4 was not. Also with version 6, we have the opportunity, should we take it, to eliminate the need for DHCP servers, because our hosts can assign themselves an address. Also, with quality of service, again, if you haven't hit this topic yet in your career, and we definitely aren't going to hit it in this course, don't worry about it, but I'll just give you a quick description of QoS. It's a great way to classify traffic so you can treat the different classes of traffic differently. You can give one transmission priority over another. You could say, for the love of God, don't drop this kind of traffic, drop this one instead, that kind of thing. It gets a little more complicated than that, I grant you. But the capabilities of it are much greater with version 6 header values. And speaking of those, I'm going to show you the version 4 header first, the IP header. And I'm not presenting it to you to memorize, but you should be aware of what it is, probably recognize it on sight. And I want to compare it to the version 6 header. So we're going to start with the version 4 header, which is what you're looking at now. And it's pretty busy. We got a lot of little fields kind of stuck in there. Source and destination address, of course, we had to bring those over to version 6, or we really didn't need anything else. But a lot of other fields here got dropped, and a couple others got revamped and renamed, and there's only one truly new field in your version 6 header. And you're looking at that header right now. That new field is flow label. There is no equivalent to that in version 4. Let's talk about each one of these fields briefly. Now, version we're going to talk about real briefly because, surprising absolutely no one, it is set to 6. Traffic class, that replaces the TOS field, the type of service field in version 4. And it refers to this field's ability to allow us to assign different levels of importance to packets via quality of service, and that in turn helps us classify the traffic class. You see where that comes from. Flow label is kind of an assistant to traffic class. There is no version 4 equivalent to this field, but this field does help with classification and QoS because it allows a packet to be labeled as part of a particular flow. Again, the name is the recipe. It is literally a flow label. Payload length, same thing as total length in version 4. Hop limit is a rough equivalent to version 4's TTL field, the time to live field. And every hop decrements that field by 1. And when that counter hits 0, TTL turns to TTD, time to be discarded, because that's exactly what happens. The next header field in version 6 is equivalent to version 4's protocol field. Source address and destination address, those are separate fields, of course, but they're same functions as in version 4, just a little bit longer, as we know very well. Now, the fields that didn't make the jump to version 6, header length, identification, flags, fragment offset, header checksum, options, and padding. All right, why did we drop all these fields? Well, for the most part, they were eliminated because they're not necessary in version 6. For example, the version 6 headers are fixed in length. Very important to know this. Version 6 headers are fixed at 40 bytes in length. Version 4 headers are not fixed in length. So if every header is going to be 40 bytes, what do you need a header length field? Don't need it, so they got rid of it. Now, the version 4 fragmentation field we talked about, you won't see an equivalent to that in version 6 because version 6 does not fragment packets. And by fragmentation, I mean packets that are broken up into smaller packets to allow transmission. Not always, but usually the reason a packet is fragmented is because it runs into an interface MTU, a maximum transmission unit, that is smaller than the actual size of the packet. So when that happens, you got trouble. Now, what should happen with version 6 is the host will perform an end-to-end, take a deep breath, path maximum transmission unit discovery, PMTUD. This allows the host to know how large the packets can be without requiring any kind of fragmentation along the way. So we got 4 switches and 3 routers here, but the hosts do an end-to-end discovery, see what the MTUs are, and then they just don't send a packet larger than that. Now, if the protocols in use do not allow for that, version 6 nodes can use an extension header, and this one is called the fragment extension header to allow fragmentation of packets. Now, version 6 extension headers are way out of the scope of our study, so we're not going to spend any more time on them here. I did want to mention that one, but if you want to read more about them, here's a bit.ly link to a handy Cisco PDF. Cisco URLs do change, but this one's been there for a while. Also, if you are watching this on Udemy, and I believe GNS3 Academy allows it as well, I'll put it as an attachment with this video, so you should see it right there where you can download it. Again, not required reading, but there's some good stuff there at the very beginning for you to read that I think will help you with your version 4 to version 6 header comparison. My friends, on that note, for now, we are going to wrap things up with IP version 6. We're going to head now into really more nuts and bolts, but some important stuff. We're going to look at syslog, time zones, some security features we haven't discussed yet, license management, all kinds of fun stuff. So take a deep breath. You deserve it. Take a break. You deserve that too. And I'll see you at the beginning of the next section.